Welcome back to Code Meets World. Today we're looking at LeetCode problem 695, which is the max area of an island. So we're given an m by n binary matrix, and an island is a group of ones representing land connected four directionally, horizontal or vertical. All four edges of the grid are surrounded by water. The area of an island is the number of cells with a value of 1 that are in the island. And we need to return the maximum area of an island in the grid. If there is no island at all, we return 0. So looking at this grid here, where the 1s are land and the 0s are water, our task is to go through and return the size of the largest island, which is highlighted here in red. And this has a size of 6, which is bigger than these other ones that are 5 or 4 or 1. Here I've drawn a smaller example of the problem that we saw in the description. So here the green ones are land and the blue zeros are water. And if we just look at this intuitively, we see that this island is length or area 3. This one has area 2, and this one down here has area 5. So in this case, we would want to return the correct answer is 5. If you watched my last video, I solved a really similar problem to this, where we were just curious about how many islands we saw in the grid. And this is just a variation of that same problem, but instead of counting the number of islands, we just want to look at how big they are. So I'm linking that video at the top of the screen, so go check that one out if you haven't solved that problem before. We're going to solve this one in a very similar fashion. So we're going to use a searching algorithm. You can either use depth first search or breadth first search because we want to explore this entire grid, but we want to search for the islands when we find them. So if I use breadth first search, the way that would look here is I would start at the top of the grid at the first value. I could start anywhere, but that's just where I will start. And if I see a 1, meaning I have found land, what I want to do is search all of the cells that are next to it. So remember, in this case, we can't go diagonal. So we either have to go horizontal or vertical. And I'll see that both of those are also 1s. So once I get to those, I will keep searching. So from this one down here, because it's land, I'll keep searching for land to the left and right. I'll do the same thing for this one, but we'll notice that all of those end up being zeros, meaning they're water. So I know the island stops right here. And I'll follow a similar strategy for the entire rest of the grid. Let's walk through an example solve of this grid using the breadth first search technique. So I'll need a couple of things to start. I'll need a variable to keep track of the max area that I've seen over the entire search of the grid, and I can set that equal to 0 to start. I will need a local area, which is the area of each individual island I see as I come to it. So basically, I'll use the local area to keep track of the island I'm on right now. And then after I find its size, I'll compare that to max area and update that as I go. The last thing that we need is some sort of queue to keep track of the nodes that we need to visit next. And queues are very commonly applied to breadth first searches. So I'll start my search at the top left of the grid, like I mentioned, and we'll ask ourselves, is this value a 1? Meaning, is it land? Yes. So we're going to add this to the queue, and now we can start our breadth first search from that node. So we go into our queue, we pop off the first value, and we start exploring from there. So we're, again, right here, and we say, okay, this is a 1, so let's keep exploring. So let me check out what my neighbors are. So my neighbors are a 1 and a 1. I'm going to add both of those to the queue. And now that I've successfully explored that first node, I need some way to mark it so I'm not going to ever go back to it again. So in this case, I can change it to a -1. So that way we never go back and explore that node again. Now we go to our next iteration of our breadth first search. So we go into our queue, we pop off the 1, and then we note that that is here. And so because it's a 1, meaning it's still land, we need to keep exploring. So now let's look at our neighbors, which are 0 and 0. And so we go ahead and add both of those to our queue, because in the next iteration, we'll have to explore those to see if it contains any more islands. Now we've explored this node, so we set it to -1, and now we keep going. So we pop another value off the queue, which is this one right here. Again, we do the same thing. So we explore each of the children, which are, in this case, each of its neighbors. So we get a -1, a 0, and a 0. So we'll add a -1, 0, and 0. And then because we have explored this node, we also set that to -1. And there's one thing I have been forgetting to increment as we go, which is the local area. So that's a big mistake. This local area here, we need to increase that by 1 each time that we see a 1 that we've explored. So I've already seen 3 of them, but after I see each one, I should be adding 1 to this. So this should be equal to 3 right now. Sorry for missing that detail. So then we go back into our queue and we see that we have a 0, but that's water, so we don't need to explore anymore. Same with that 0. A -1 means we've already been there, so we don't need to explore that one. And then 2 more 0s that we don't need to look at. And now our queue is empty, so we can say, okay, is 3, which is the size of the island we just looked at, is that bigger than our max area, which is currently 0? Yes, that's bigger. So we can set our max area to 3, reset our local area, and now we're completely done with that first island. Now, all of that happened from just starting by exploring this top left node. Now we continue that outer for loop to look at this node next. And we ask, is it a 1? No. So we keep going, and eventually we get to here, and now we found another 1. So we repeat this process of adding that value to the queue, starting our breadth first search. So the first thing we do is pop off a value. It's a 1, so now this time I'm not going to forget my local area. We need to increase by 1 because now we're looking at a new island. We're right here, we look at all of the neighbors, which is 2 0s and a 1. So we add the 2 0s and the 1, and now we mark that node as explored, and that completes our first round of breadth first search here. So now we go back into the queue. We can ignore the 0s, but then when we find the 1, we need to pop that off. We need to add 1 to our local tally, and then we need to explore from this node, which gives us a 0 and a -1. So we'll add those both in. And then we need to mark this node as explored. And so now we go back into our queue and see that we have a 0 and a -1, which we can ignore. And now we're finished because the queue is empty. So our local area is equal to 2, but this is not bigger than our max area. So we don't update our max area because the island wasn't bigger. And then we can clear all of this and keep iterating. We will then loop over all these other values in the grid all the way down until we get to this one right here. And again, we're going to do the same process one more time. I won't write it all out because I've already done it twice, but we'll go through the same process of adding the 1 to the queue, exploring its neighbors, and popping off all the way until we set all of these values to -1, like this. And remember, each time that we find the 1, we will end up adding 1 to our local count, which will give us 5. And we can say at the end that 5 is bigger than 3. So we update our max count, or our max area, to be 5. And now we've finally got to the end of the grid, meaning we've looked at every island. And so now we can just return this max area is 5. It's also worth pointing out that whenever I save a value into the queue, for example, if I want to save this 1 in the queue. In my example, I was just writing a 1 like this, but what if I have multiple 1s in the queue? I'm not going to know which is which. So instead of saving the values just as a 1 or a 0, I'm going to actually write in the coordinates of them. So that 1 would actually be at row 0, 1, row 2 in column 0, 1, 2. So this value here is actually at location 2, 2 in the grid. And I'm just going to do that so that I can keep track of multiple 1s or multiple 0s being in the queue at the same time. The first thing that we'll do is create our max area variable, which we can initially set to be 0. And then we want to loop over the entire grid. So we can say for I in range, and we can go over all of the rows by saying the length of grid. And then we can loop over all the columns by saying for j in range, and we can just take the first row of the grid like this. So now we're looping over all of the rows and columns. And what we want to do is start a breadth first search from any 1s that we see. So if grid ij equals a 1, we know we need to start a breadth first search. So we can say bst starting from position I, j, and we want to be searching in grid. In this breadth first search, I keep saying binary search tree. This breadth first search, BFS, not binary search tree. This breadth first search is going to return the local area, right? So this will return a local area. So what I can do is actually set the max area equal to the max value of whatever max area is currently and whatever the breadth first search returns starting from this value. At the end, of course, I will need to return the max area. So now we're just missing our breadth first search functionality. So I can make that as its own function. So I'll call that breadth first search, and that'll start at a given row and column, and it's going to search in the grid starting from that position. So again, looking at this example that we see here, say we find this 1 first, well, we're going to start the breadth first search from row 0, column 2, and look for other 1s starting from there. So we're going to need our local area, and we're also going to need, we can set that equal to 0, and we're going to need a queue, and I'm going to use a deck for that. So I'll call it toVisit, and I can set that equal to a deck, and I'm going to add the initial value that we need to search for to the deck. So this is what I mentioned here, where I'm going to be using the coordinates of the value that I want to look for. So this is initializing an empty deck, and then I'm adding to it that first tuple, which is the row and column. And if you haven't worked with a deck before, it's just a Python provided queue implementation, and I'll show you how we can add and pop values from it. And this is better than an array because an array is just a stack. We can add and pop from the right-hand side, but a queue we need to add from the right, but pop on the left. So that's why we're using it. This needs to be a comma, and then we will start our search. So we will say while toVisit, because remember, we need to search while the queue is not empty. So saying while toVisit will keep looping while there are values there. And the first thing we'll do is set our I and j equal to toVisit, and this is where we can say .pop left, which will remove the leftmost value of the queue. So in that case, it would remove, for example, that value there. So we'll pop left, and because this is a tuple of the coordinates, it'll set our row equal to I and our column equal to j. What we would like to do is check if grid at ij is equal to 1, because if it is, we know that we need to visit it and keep exploring. But before we can check grid ij, we need to make sure that we haven't gone off the edge of the grid, so either above, below, or to the left and right of it. Because when we explore a neighbor, we might accidentally go off the edge of the grid. So we can say if I is less than 0 or I is greater than or equal to the length of the grid. Likewise, we can say or j is less than 0 or j is greater than or equal to the length of a row in the grid. If any of those things happen, we can just skip this one because we don't want to process a value that's off the edge of the grid. Once we've checked that, now we can safely ask, is the value in this position a 1? If it is a 1, we need to increment our local area by 1, right? Because we've now seen a 1. So we need to keep track of our island size. So local area plus equals 1. Then we need to explore from the island. So we need to look at all of its neighbors, left, right, up, and down. To do that, we can say to visit, and we can use the extend function, which means we can give a list of values and they will all be added to the queue at the same time. You can also use extend with arrays in a very similar way. So we're going to need to add 4 values, which are the locations, the coordinates of the cell up, down, left, and right of the one that we're currently on. So we can do that by saying, let's go down a row by adding 1, staying in the same column. Let's go up a row while staying in the same column. Let's stay in the same row, but go over 1 column. And finally, let's stay in the same row, but go left 1 column. And that should be correct. Yeah. So we've added all of those, meaning we've explored from that island. And now remember, the last thing that we need to do is set the value after we've explored it to be -1, so we don't return and explore it again. So we can set grid ij equal to -1, like that. Afterwards, after we do all of this and we loop over until the queue is empty, once it's empty, we exit the while loop, and then we can just return the local area like this, which gets passed back down here and is compared with our max area so that we can find the largest island. Let's go ahead and run this and see if it is working or if we have any problems. So that's been run and it is working for both of the test cases. So we'll go and submit, see if we're passing. Yeah, and we are. That's working. And this is, I think, about the fastest that you can do it because it's just a breadth first search, and that's the fastest way to explore a graph and to solve this problem. It's also really good on memory because we just have our queue. So yeah, this is very similar to the last problem. Let me know in the comments if you have any questions or suggestions or you see a better way to do this. I will see you in the next video.